What we want to do next is we want to focus our attention on one particular type of structure, one particular type of class of drugs based on the structure. So we're going to talk a lot about alkaloids over the next few slides. So alkaloids are plant compounds that are known for their alkalinity. Alkalinity means that they're basic. They're not acidic, they're basic. They usually will have a very bitter taste to them. Chemically, they all have an amine group, so they all have a nitrogen containing group, that they're generally an organic compound with a nitrogen. The nitrogen makes them special. In general, all of these are highly addictive. They're also constipating agents, so they will, oh, how should I put this? They will change your bathroom behaviors. Some common different alkaloids include caffeine. That's my drug of choice. I have my sweet tea sitting over here on the side. Nicotine is also an example. And then opiate narcotics. Narcotic is a substance that produces a stupefying, dulling effect and induces sleep. So let's break down some of these different alkaloids for you. So caffeine, again, it's an alkaloid. If you were to look at the structure on the bottom right-hand corner, we have a carbon-based compounds, but look at all of those nitrogens. Now, caffeine is going to stimulate the central nervous system and the heart, and it also heightens the sense of awareness. Sometimes people will talk about drinking coffee to get a jolt to their nervous system. I personally can't do coffee. If you saw me at 7:30 in the morning, I am generally a morning person, and most people will say there's no way in the world I should take coffee with how hyper I am at that point in time. Your soft drinks have about 60 milligrams of caffeine added to them. A regular cup of coffee has between 100 to 150 milligrams. If you drink decaf has the caffeinated removed. It's decaffeinated. Down on the bottom, we actually have a picture of some coffee beans. These are the berries of the coffee plant. And they do contain that caffeine, which are then harvested to make your good old coffee. Now, caffeine does have a lethal dose. Um, it's about 10 grams for the average size of adult. So what they say is that the LD50 is about 0.13 grams per kilogram. Okay, let's break this down because I don't think we've covered it in the book yet. LD50 is the lethal dose of 50% of a population. So if you had a large population that you gave them caffeine at the rate of 0.13 grams of caffeine per kilogram of body weight, it would kill half of that population. Or if you were given that amount, you would have about a 50-50 chance of living or dying. That's kind of what the LD50 is starting to look at. Now, for the average size adult, they say that this will range from anywhere from 70 to 100 cups of coffee. Now, that doesn't mean if you drink a cup of coffee for 70 days, you have a 50% chance of dying. I am not saying that. What this means is that if you were to ingest the amount of caffeine in 70 to 100 cups of coffee all in one sitting, so you don't get up, you don't get to go to the bathroom, you don't get to do anything like that, that would be the amount of caffeine where a large population would have a 50% chance of, it would kill off 50% of that population, or you would have a 50% chance of dying from that particular amount. Now, every individual is going to behave slightly different, as we're going to find out in a later chapter. But that is what is estimated for an adult. Now, if soft drinks have 60 milligrams and coffee have 100 to 150 milligrams in them, ooh, what about those monster drinks that people are liking? Now, deaths due to caffeine don't necessarily have to be due just to the LD50, as we talked about just a minute ago. There are other issues, especially when you start dealing with the heart. If you're going to give the heart a jolt, you might have some other issues that are going to occur. The next alkaloid we want to look at is nicotine. Nicotine is a highly poisonous alkaloid that occurs in tobacco leaves. So down on the bottom right, we have the structure of nicotine. Notice the nitrogen's in there. And then we also have a picture of someone harvesting some different tobacco leaves. nicotine will vary drastically depending on how it enters a body. So I was talking one time to this guy who he was a chemistry teacher, and he was doing some lab clean out. So he's going to different labs and he was cleaning them out. So he got to this one, and normally he would wear gloves, but he wasn't this particular day. He got to this locked cabinet at like the back corner of this lab and reached in and pulled out this bottle, and it was just covered with this black grimy stuff, tarry type substance. And as soon as he grabbed it, he knew he was in trouble. And it turned out it was a bottle of pure nicotine. Nicotine, whenever it's absorbed, it's extremely lethal. So just from grabbing this bottle, it didn't kill him, but he ended up getting very sick. He said it was like flu-like symptoms for 2 to 3 days. Sicker than a dog, probably the sickest he'd been almost his entire life. If you look at the LD50 of nicotine for oral administration, it's about 0.23 grams per kilogram, which is actually less than the caffeine that we just talked about. So how deadly nicotine can be does depend on the means of how it enters the body. Now, nicotine, the most common place we'll hear about it is in cigarettes. Cigarettes also contain some tarry substances that are possibly, probably more than a little possibly, cancer causing. And one of the big issues that we have with cigarettes is secondhand smoke. Now, I'm assuming that you've heard about secondhand smoke and you've been preached about secondhand smoke since you were a little kid. So I'm not going to go into that particular lecture right now. We also have an issue with carbon monoxide in that the substances being produced, instead of being able to go to a whole carbon dioxide, that some carbon monoxide is also being formed. It's estimated about 400,000 people die each year in the U.S., alone that is, from smoking-related causes, both with cardiovascular issues and also cancer. Now, I figured you probably had some previous experience talking about, we'll just say talking about, we're not talking personal experience, with your caffeine and your nicotine. Opium is sometimes a little bit different. You might not know a whole lot about opium. You've heard stories, you've heard things about it, but what is it exactly? Now, this is considered to be a narcotic. A narcotic dates back to a Greek word meaning numbing or stupefying. And it's the dried sap of poppy. So if you've watched Wizard of Oz, and this will tell you how, I don't know, I guess just innocent-minded I was as a kid. In Wizard of Oz, they have him, and they are going down the yellow brick road. Dorothy and her gang of the Lion and the Scarecrow and the Tin Man and her little dog Toto. And they get to a big field of poppies, and they go to sleep. And I never could figure out, what are they trying to do here? Well, it wasn't until I started learning about this, I'm like, oh, okay, that's what's going on. So the dried sap of poppies is what opium is. So up in the upper right-hand corner, we have a seed pod of opium, and we can see some of the liquid that they're going to get that sap from. They're going to get that opium from. Opium has many, many different components in it. Codeine and morphine are a couple of the example. Opium itself probably dates back to the Sumerians about 6,000 years ago, but the first clear reference to opium is in Greek writings about 300 BC. Now again, there's many, many different components of opium. About 25% of those are alkaloids. So we're going to look at a few of those examples. The first one I want to look at is morphine. Morphine is an analgesic. Oh, what does that mean? We talked about this term a long time ago. Analgesic is a pain reliever. It's also a cough suppressant. So morphine is actually the major alkaloid of opium. About 10% of opium is actually morphine. It was first isolated back in 1803 by a guy named Frederick Sir Turner. and it's named for Morpheus, the Roman god of dreams. It gives you a variety of psychological responses, anything dealing with apathy, where you just don't care about anything, to euphoria, where you are just on top of the world. Codeine is next. Codeine is a less powerful analgesic, so not quite as good of a pain reliever, but it is one of the strongest cough suppressants known. That's kind of interesting there. It's actually a standard by which other cough suppressants are compared. Now, this was first isolated from opium back in 1832 by a French pharmacist. It is also used in Tylenol 3. So Tylenol 3, I always got a prescription for that when I had the kids as I was leaving the hospital. It's Tylenol with a little bit of codeine mixed in. Again, it's a pain reliever. It's an analgesic. Not quite as good as morphine or some of the other ones that we have, but it is a pain reliever you could use. And again, one of the strongest cough suppressants known. Papaverine down the bottom, it has been used to relax smooth muscles such as blood vessels, stomach, intestines, bladder, and uterus, and help dilate vessels in the brain. So a couple of the things that, couple of the different parts of opium. But all of these are pretty addictive. So we want to try to find something that's less addictive. So let's see what we should do next. Okay, so we've been talking about opium and the different alkaloids that you could have, and how, a lot of these are actually quite addictive. So we want to find something that's going to be effective but less addictive. So here's what happened. So the first one we're going to look at is diacetylmorphine. So you start with morphine, and just like aspirin, we're going to add some acetyl groups. So we're trying to get something that's going to be less addictive, something that's going to be a less, let's see if it's more easily tolerated by the body. They first did this back in 1898 by a German dye manufacturer. So whenever they added these acetyl groups to morphine, they ended up with heroin. Very powerful analgesic. Very, very good pain reliever. Very good cough suppressant also. But it's one of the most addictive drugs known to man. They say that, you take it once and you're just kind of screwed for life there. So, and be very, very careful. One of the byproducts of adding the acetyl groups to morphine is acetic acid. And acetic acid is what's in vinegar. So if in a certain area, I know in France they were doing this a lot, they actually train their police dogs to try to pinpoint or be alerted to the smell of acetic acid, so that they could see if whether or not heroin was being produced in a certain area. Let's see here. Oh, OxyContin down there at the bottom. So this is an extended release form of oxycodone. So we want something that would last a longer period of time, that you don't get all the dosage right at the beginning. It's an extended release. Well, people are kind of crazy. They changed the structure just a little bit. It's over on the right-hand side. Down on the bottom, it shows the structure, the reaction for our heroin, name for the heroic feeling that you get. Back to OxyContin there. We wanted an extended release form so that we would have less of a problem with addiction. But then what people figured out is that if you crushed up the tablet, they would snort it to get the effect immediately. Don't do that. That's bad. That's evil. So it was actually reformulated back in 2010 to help avoid that particular situation. Now, both of these are considered to be semi-synthetic opiates. Okay, what does semi-synthetic mean? Semi-synthetic means that it's based on a natural product, but we have chemically modified it. So we've done something to it to where it's not exactly the natural product anymore, but it's based off of that natural product.